Okay, today we're going to begin the gallery of graphs topic or area of study, and when we're going to look at all different types of graphs. So when we always have a basic graph, and then we'll do some transformations. So transformations when we move the graph left or right or up and down. So we saw a little bit of that when we did quadratics. So we saw, when we had, if we have x plus 2 squared minus 3, if that was the formula, you knew that it moved the quadratic to the left by 2 and down by 3. So we saw like our quadratic would do, and that was the turning point. So we saw something like that, for example. Okay, so we're going to look at all of those things, but we're going to look at different graphs now. So the first graph that we're looking at is the rectangular hyperbola, and that is when we have the basic formula y equals 1 over x. So the 1 over x can also is the same as saying x to the power of -1. Okay, so if we look at a basic graph of y equals 1 over x, we've drawn it here in the green, and we can see that it goes along in the two areas there, so down here and down here. And so what we're saying here is we can see as we approach 0 on the y-axis, we just keep getting a bigger x value. So that's what we're saying with approaches infinity. And if we look over here, in the bottom section, we can see as x approaches 0, from the negative side, it also just gets more and more negative. So we can see it never touches the x and y axes, and when it just goes right up really close, and when we say it goes right up really close, they're called asymptotes. So for a basic 1 over x graph, the asymptotes are y equals 0 and x equals 0, or the y and x axes in this case. So that green graph will never cross. So yeah, so let's go, and now we're going to look at what happens when we do some transformations. Okay, with the transformations, so first of all, we're having a look up here at the dilation. So dilation's whether it's getting skinnier or fatter. So up here in the green, I've drawn the basic graph, so we can see that on the axes there. Now with the pink, we can see the dilation. So when it's times, it becomes a bigger number on the top. We can see that it gets a bit fatter or further away. So we see down the pink. And if we have a number, if we're dilating by a small number, say a half, so down here, we see it gets skinnier than the basic graph. Okay, so then another type of transformation is reflections. And reflections is when we see it flip over because of the negative. So here, always in the green, I draw the basic. And here we can see in the pink, the formula has a negative. And when there's a negative, when the negative is up there on the top like that, we can see it's actually reflecting in that x-axis there. So, so this bit is flipped down there, and this green along here is flipped up there. So, yeah, we can see the negative flips the graph or reflects the graph in the x-axis. Now, we've got another type of transformations. So transformations is the general term used for all of these dilations, reflections, and translation. So what a translation is when we move it left or right. So if we have a look at this example here, we can see we've got a 2 over x minus 1. So we've moved this, we've got another little bit into our formula here. So the -1 moves the graph to the right by 1. So if you're thinking of this graph, the best way to redraw it is that we're going to think that the asymptote moves right by 1. So we can see here we've moved our asymptote over, and the basic green graph, when it's moved, and then we see the red line, and that's that new formula. Now note when you do some translations and you move it, you will now get a y-intercept. So if you had to, if they ask you to state the y-intercept, remember that the y-intercept is when x equals 0. So you just pop that into your formula. So you would have y equals 2, 0, minus 1. So y equals 2 over negative 1. So y equals negative 2. So the y-intercept is 0, negative 2. So you could pop that in there, and where I could say that was 0, negative 2. Okay, so we're going to continue on the next page and look at other translations. So with the next translation here, we've got, I've got here, down here, we're moving the graph. So we've got pretty much a basic graph 2 over x plus 3. So that plus 3 moves that y asymptote up by 3. So you can see up here, we've moved the y asymptote, and then we draw our new, the new graph in, bounding onto those that new y asymptote. And once again, we can see we get a x-intercept now. So if you had to find the x-intercept for this one, we let y equals 0 into the formula. So it'd be 0 equals 2 over x plus 3. So move the 3 over, got negative 3 equals 2 over x. So x equals 2 divided by negative 3. Okay, so here you could write that little intercept is 2 over negative 3 comma 0. All right, so over on to the right, we can see another graph here. So we've got y equals 2 over x plus 1 minus 3. So we've got the basic hyperbola would just be asymptoting on the x and y axes, but this plus 1 has moved that one over to the left. So here, x equals negative 1, and this minus 3 has moved the y asymptote down to negative 3. So then we redraw our graph bounding onto those asymptotes, like we can see in the red. And then we see once we do that, we get an x and y-intercept. So you can just go about finding like I have on the other ones. All right, so overall, we can see when we have this basic formula that if we have y equals a over x minus h plus k, we can see that that value in h becomes the x asymptote. So look up on the one on the right here, see how the h value was actually plus 1, so the asymptotes become negative 1. And you can see the plus k was minus 3, and so the y asymptote became minus 3. Okay, so that's our first graph for the gallery of graphs, and the next lesson we'll do a different type of graph. Thanks.